Welcome, Hornets, and thank you for showing up today and listening to my video. Today we're going to be going over part 2 of our assignment number 4. And I stopped at number 15 on the last video, but I'm moving up to number 23 so that we can take a look at numbers 23 and 25 and get an idea of how to do absolute value problems. So right here, you'll notice here's number 23. And it is the integration from 0 to 5 for the absolute value of 2x minus 5 dx. And you have two choices to do this, but you have to decide how you're going to do it. All right? So option 1 is to graph this thing. Now we know it has a vertex point sitting at 2.50, and it looks like that. Now, if I'm going to graph it, I know that this side is 2x minus 5, but this side is going to be negative 2x plus 5. And I would have to now integrate both of those. Now I could do that from 0 to 2.5 and then continue all the way up to 5. And that'll do it. All right? But it's a lot of extra work. It means finding two different equations, and that can be more difficult. So instead, what I would like you to think about is this act of an absolute value making the negative portion opposite. And the negative portion is going to be that piece which is to the left of the vertex point. And we're going to create two distinctly different integrals. The first integral is 0 to 2.5 of the equation 2x minus 5 dx. Because this is the left side, we're going to make it a negative. And then we're going to add to it the positive side. 2.5 to 5 of 2x minus 5. Now what you're actually doing is the graphing process without having to find the line. You graph it, you've got to find the line so that you can integrate that line from 0 to 2.5. Well, if you notice, if you distribute this negative into this binomial, you're going to get negative 2x plus 5, which is the same thing that we called that other line. So you are doing the same thing, but you're not graphing it. If you want to graph it, you can, but you don't have to. Now I can simply look at this as x squared, and I'm going to put the negative out in front, minus 5x from 0 to 2.5, and then I'm going to add this piece, which is x squared minus 5x from 2.5 to 5, not to 0, but to 5. And now I'm going to integrate both of these. Now as I do, I end up getting negative 2.5 squared plus 5 times 2.5 plus 25 minus 25 minus 2.5 squared. Double negative is plus 5 times 2.5. And this is what I'm going to work with. Now you'll notice, as I go through and do this, I'm adding each of these pieces up one at a time, and I end up getting 12.5. So 12.5 is my answer. Let's take a look at number 25, please. Number 25 is also an absolute value problem. And this problem is the integration from 0 to 4 of x squared, absolute value of x squared minus 9. Now, this graph, if we were to graph it, the portion that's down below on this quadratic, because it's going to go like this, this portion down here flips. That's what the negative does when I do this. And I'm going to be going to my vertex, to my 0, and we know our 0 is at 3. So here we go. 0 to 3 of x squared minus 9 dx, opposite, plus 3 to 4 of x squared minus 9 dx. And this is what we're going to work with. So we have negative 1/3 x cubed minus double negative plus 9x from 0 to 3 plus 1/3 x cubed minus 9x from 3 to 4. And we're now going to do both of these pieces, add them together to find our answer. So you'll notice we're going to get negative 27 divided by 3 plus 27 minus 0. This is now giving me 64 over 3 minus 36 minus 27 over 3 minus 27. This is going to become a double negative and give me twice as much. This is a double negative and is giving me twice as much. So I now have a 54, and I'm adding to it 54/3. Now, we know that 3 goes into this, and we're just looking at a negative 18. This one is going to give me 21 1/3 minus 36 minus 9 plus 27. And that's where that 54. So let's get rid of those so we don't add them twice. We're now going to be adding everything together in order to find our area. Here we go. Negative 18 plus 54 plus 21 1/3 minus 36. And I'm going to get 21 1/3. Let's make that larger. It doesn't look like the mixed number it's supposed to be, and I don't like that. 21 1/3. There we go. Now we can check our answer just as easily. Let's go ahead and do this. I've already put it into my calculator under Y2, and I'm now going to hit Math 9, integrating from 0 to 4, and I'm going to put alpha trace Y2 dx. Enter. And we get the exact same answer. Once again, you have your choice. You can either graph it and do each piece separately, or you can find that point, that x-intercept. And we did in both cases. For an absolute value that's involving a linear, we find the vertex point. When we're talking about a quadratic, we're looking for the x-intercept where it's being reflected up above the x-axis. And we then take the two pieces and add them together. Alrighty, continuing. Now, there are a couple of other problems that we can work on that you can look at. For example, number 29 is now involving our trig. So let's take a quick look at number 29, please, just so that we get an example in this grouping. So we have 0 to pi over 4, and I'm looking at 1 minus sine squared of theta, and it's over cosine squared of theta d theta. Now, when you're doing this, what I want you to stop and think about is, do we know what 1 minus sine squared theta is as an identity? And yes, we do. It happens to be cosine. So we're really looking at 0 to pi over 4 of cosine squared theta divided by cosine squared theta, d theta. And this is simply 0 to pi over 4 of d theta. Now, when we take our integral, we are left with theta. So we end up getting theta from 0 to pi over 4, and that's pi over 4 minus 0 equals pi over 4. And there's my answer. So notice the trig is pretty much the same. We start off, we write down our problem, we recognize our identities. If we can, we substitute them, and then we evaluate following the fundamental theorem of calculus. And this is where you need to know all of your anti-derivatives, or that integration processes that we learned in 5.2. So please keep that in mind. Let's now go ahead and take a look at numbers 49. Now in the grouping of 49 through 53, we're talking about the mean value theorem for integrals. And the mean value theorem for integrals, if you recall in our notes, simply said that we are trying to find the value. So let's just write down our theorem. We're talking about a to b of f of x dx, and it has to equal f of c times b minus a. Now, you'll notice if I have this function, in order to find my mean value, I'm going to want to figure out what is the integration of a to b of f of x divided by b minus a equaling f of c. Okay? And we're trying to find this value c. So we want to figure out where does this equal this on our calculator. That's our goal. So let's see what they've given us. Number 49, we are given f of x is equal to x cubed. And we're working from 0 to 3. Okay? So we already can put this in as the integration from 0 to 3 of x cubed dx divided by 3. And we want it to equal x cubed. This is going to give us a value, and we are then going to have it equal this one. So let's go ahead and find it. And there went my lights again. Please forgive me, but it is frustrating. And as this school doesn't really care, I don't know what to say. I'm sure they do, but it's still frustrating me nonetheless. So I'm going to put in my fraction, and I'm now going to put math 8. And math 8 is my x. It's going, let's try that again, Mr. Lampclear. We need the fraction, math 9. That's what the lights have done to me. So we have 0 going up to 3, and I'm now going to put in x cubed dx, and I'm dividing by 3. Then I'm putting x cubed, and I'm going to go ahead and I'm going to zoom this out. So I want zoom 6 to see a good picture. Let's see what we get. And keep in mind, this is between 0 and 3 that we're looking for. So if it goes out, we're not going to have a value. Okay. So here we go. Notice in this cubic, I have 2 values. I'm now going to narrow my window, 0 to 3. Here we go again. Now, the whole idea was for you to be able to see what was happening. Let me zoom in on this so it's easier to see. The darkness, unfortunately, is making life very difficult. You notice that intersection. The intersection between the integration divided by 3 equal to x cubed is the value of c we're looking for. So we're now going to go second trace, find the intersection 5, enter, 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 and our value is 2.598. And that is what we are looking for. All righty. I'm going to go ahead and I'm going to stop the video here. Please be aware of that. I need to go and turn the lights back on again and then continue. So we'll go to part 3 next. Thank you for watching, and once again, if you found this helpful, please make sure you click a like. Thank you very much.